Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. Linode is sponsoring us this week. Check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for your next project. We are also sponsored by Sentry this week. Stop hoping your users will report bugs. Sentry's real-time tracking gives you insight into production deployments and information to reproduce and fix crashes. Check them out at getsentry.com and use the code podcastinit at sign-up to get a $50 credit. Hired has also returned as a sponsor this week. If you're looking for a job as a developer or designer, then Hired will bring the opportunities to you. Sign up at hired.com/podcastinit to double your signing bonus. The O'Reilly Velocity Conference is coming to New York this September, and we have a free ticket to give away. If you'd like the chance to win it, then just sign up for our newsletter at pythonpodcast.com. To help other people find the show, you can leave a review on iTunes and tell your friends and coworkers. And please join our community. Visit discourse.pythonpodcast.com for your opportunity to find out about upcoming guests, suggest questions, and propose show ideas. Your hosts as usual are Tobias Macy and Cris Patty, and today we're interviewing Cris Medina about test engineering for large and complex systems. So, Cris, could you please introduce yourself?
Hi everyone, my name is Cris Medina. I'm a computer engineer, and I've been working in test or some form of test engineering for the majority of my professional career. I've done everything from simple software tools to complicated hardware bugs and all the back-end infrastructure and planning required to have a large project go through a multi-month cycle of testing.
So, Cris, how did you get introduced to Python?
Actually, that was pretty interesting situation. So I've been talking about things I've made. I wound up doing this test management framework, and I was working on some back-end stuff, and I was sitting around the office talking to some coworkers about it, and this Perl versus Python battle ensued. My code was in Java at the time, and so I knew I needed to do something a little more elaborate, so I've been looking at other things, and I knew enough about Perl that I wanted to try something different, and and so then after that interesting exchange, I was like, oh, yeah, maybe I should give Python a look here, and never looked back since. It's pretty cool.
So, to get us started, can you share your definition of test engineering and how it differs from the types of testing that your average developer is used to?
So, testing in general is a pretty wide field that encompasses a whole bunch of stuff, like all kinds of different methodologies and ideas. Everybody has a different way of going through everything. But, if you think of things at the very minimum where there's a single developer that's focusing on a particular function they've written, doing things like, say, unit testing, which for the most part is going through and verifying like all the specific methods or whatnot that they've developed, and things start getting more complicated once you move beyond that step and start looking at how that piece of code interacts or integrates with other pieces across your system. And so it's important to make that distinction between just testing just to poke at everything that you have, which I'd call that kind of like a brute force, and like the actual engineering approach where you have to make a decision of how you go through things. So in my opinion, most recently a lot of focus has been around unit testing and continuous integration, mostly because of the benefits we've been able to get from automation, and all that stuff has a great value, especially when you're doing lots of builds, so you can find out where your code breaks and all that kind of stuff. But when you step back and you look at the larger process of how your product interacts with different things in your environment that your users may be involved with, that's when you start getting into actual engineering. You have to me, it involves the larger process by which you analyze the system, its design goals, its objectives, the intended use. You contrast that against the actual patterns that your users are following when interacting with it, and the side effects of all of those functions. And then you, as the engineer, come up with recommendations on how to improve upon the system, whether it's by writing bugs or just communicating with development itself, or to change your actual goals of where you think you could take your product, right? And then figuring out how to do all that stuff is like a large process that involves looking through design specs, reading industry standards, identifying your marketing requirements, looking at compatibility goals, and your intended user experience, which then, puts everything together for you to come up with like a number of tests, usually in the thousands, likely in the tens of thousands, that verify the behavior or the function that you're looking for. So to me, the actual engineering step is the creative step of actually designing a test, right? You're not writing code. You're not as a base function. You're designing. You're trying to figure out based on how someone's already existing code or system functions, how best to approach testing it such that you can understand its intricacies and how it ties into other aspects of your product and its environment, how to define your suite such that it's you have an individual test that's repetitive as it needs to be, because sometimes you want things to repeat a little bit, but obviously repeating things a lot is a bad thing. How to figure out how to not get sucked into all the possibly millions of permutations that your product might be supporting, especially if you have like open standards that involve allowing you to like say on some systems run through a compatibility matrix of things that you're supposed to work with, and when you start thinking operating systems and drivers and things like that, you got to figure out how to split things up such that you can focus on certain areas specific to the time frames that you have allotted for your testing, and when you do that, you gotta kind of, some people do this formally, but you gotta figure out how to make it so that your tests find failures quickly, sooner rather than later, because the sooner you find them, the cheaper it is to fix them. You have to then, like, with an idea of what you're going to do, then you got to look at what infrastructure and hardware and what your test bed looks like, so that you can then take those resources you have available and apply them the most efficiently to the testing you got to do, and then and efficiently, actually means efficiently, doesn't mean just maximizing it, because sometimes you want like actual representative workloads where you don't necessarily want to maximize every single use of whatever your product might be. And when you also got to look at debugging and writing bugs and identifying where those failures should be. Which bugs should you write? What should the severity of these be? What are the impact to my customers? Given this list of bugs, which ones have priority to get fixed? Which ones should I just given my time frame, which ones should just become a limitation? And things like that.
Yeah, and also with all the different moving parts in any system, the understanding the various failure modes and how those failure modes can interact is incredibly complex and just becomes exponentially difficult to comprehend. So figuring out where the different touch points are between the systems that interact with those various failure modes to make sure that you have those cases covered is critically important to making sure that you have a robust and fault-tolerant system as well.
Right, and then like your failure modes have failure modes too, right? When you start getting into something really really complicated, I have spent quite a bit of time doing, reliability testing, availability testing. So where you gotta verify that the system you've designed actually fails in a designed way, such that your customer can properly manage all that, and then usually when you run into folks writing code, you don't really write the code to handle, you handle your exception fairly quickly, but how are you going to communicate that to the user? How is the user going to recover? A lot of people kind of forget about that part, and then when you get into these weird situations, you wind up with some interesting exchanges of, well, that only happened 1% of the time. There's the probability. Should I bother fixing this? It gets pretty interesting.
Yeah. Are there any industries where this kind of testing does not become necessary very often?
Well, when you're making something really small, right, that might not be a thing. But when you're involved in a system that has a high level of integration with some sort of third-party module, and that third party doesn't have to be like somebody in a different company or organization. It might just be somebody in a different team, where you don't really control the release cycle of that piece of code, and you're just kind of using it, right? Um, you write a simple way to think about it would be you write an application, you're just using whatever Linux kernel version you're on. But if that Linux kernel revs, then you're gonna have to go back and do some work, right? And if you run through and do some testing on your application and you realize that there's a bug in the Linux kernel that requires you to make a change, you can't expect the folks that wrote the kernel to go do that just for you, right? There's a whole other system that you're just a user of. Maybe at some point in time they'll integrate it and pick something up, but then you're gonna have to handle that use case. And so identifying that type of stuff is fairly important. Like a lot of folks, it's you don't really think about it ahead of time, especially when you're talking about something like an operating system. And my experience has been the majority of my time has been in servers, where you have this huge system where it's not just hardware, right? You have processors, you have memory, you have buses in which you can plug. It's a standard slot, so you can plug adapters from dozens of manufacturers. Some of them comply to the actual standards, some of them do not. Some of them just have bugs that don't that in their implementations of things, and so your stuff needs to be able to identify those systems, and that's what gets into compatibility and permutations, because when you start adding things together, you wind up with this huge mess of stuff that even the mechanicals of where you put things matters. Like, can your server fit into the proper proper measurement, like use the units height of your racks. Like, can any card fit into the area that I made for this slot? And there are some cards that might have a few extra things in their PCB that make it just a few millimeters too high, and you can't use it. You don't want the customer to find that. And then there's like all the like underlying things that like complicate that even more. So like a server, that's just the hardware, but like a server functions through a bunch of firmware, which UEFI these days, which used to be BIOS, right? And there's usually some form of diagnostics or systems management backend that enables the whole thing. And the systems management takes care of, should my server continue running when the temperature is too high, or this adapter, or more likely this memory DIMM generated a fault. Should my server reboot? Should I just? And then these days, processor architecture and memory controller architecture gets even more complicated, to where a failure shows up in a DIMM, and there's that gets detected by a memory controller, which then it gets forwarded to a piece of firmware running in UEFI, which then puts entries in a certain location to notify your operating system, which is then running some driver that's verifying all of these, checking all of these things. And then maybe you allow the operating system to make the decision, and you just, as the designer of the platform in which that OS is running, you just say, well, it's up to you what you want to do with this, So like a lot of times you can design for a lot of that ahead of time, but most of the time you wind up finding all these like weird interdependencies and intricacies while you're actually running tests.
Yeah, and another thing too is that most people tend to think of testing as something that you do once your code is written and before you release it, but there are also runtime tests that you can do to make sure that the environment that your application is running in fits your expectations, so that when you first release it, you're not then surprised when 2 weeks down the road, it actually hits one not often used subroutine, and all of a sudden that subroutine blows up because something that you were expecting to be there didn't actually exist.
Right. And once you get things sufficiently complex, a lot of times you just kind of have to have a method in place for dealing with with those weird exceptions that you just find later, because it's just almost physically impossible to be able to go through all of it, right? Um, there's a when you like multiply all the possible things that you could do in some of these systems, you put different OSs, your different drivers, your different memory, your different processors, and all the different cards that you can stick in there, and then all the different environments in which you can use it. And then, if it's too cold, maybe the electronics had a race condition because of some weird design flaw that you didn't even notice. And so obviously there's testing specific to those extremes, and there's testing that goes into vibrations and drop tests and all kinds of stuff as well when you get into like physical systems, right? But if you stay on the software, a lot of it is just like how all these things interact, and the more, and as we progress and things become more and more open, the more and more open APIs that you use, the more and more weird situations you can get into. Like if you write some software that uses the Twitter API to go look at your timeline, for example, that doesn't necessarily mean that that piece of code is actually going to function if you like put it against the fire hose where it's getting a ping, hundreds of pings a second, right? So
I also think testing can be a guardian against unintended complexity and the negative effects that brings to bear, right? Like you think I'm just writing this little script, and then suddenly that little script has grown and it's evolved into a whole, production application or subsystem, and you think, oh, I don't need to test this. It's just a tiny thing, but really it almost never is that way, right? Like if any code that works is destined to grow or evolve at least. And so testing helps you guard against that going in a really bad direction.
And that's where the engineering steps is really important, right? If you, I can't tell you how many situations I've been in where like we receive one piece of firmware that's like, oh, we just changed these couple of bits here. Don't worry about it. You don't need to test anything else. And we're like, well, but those couple of bits get, involved in this function here and that function there and that function over there. So we're going to have to test all this stuff and give me 2 weeks. And then they're like, no, you don't have 2 weeks. So you get into an interesting situation where you have to make a choice, right? And a lot of it is an engineering decision of what's the risk, what's the likelihood, right? And in order to do that, you need to be able to have like a good picture of what it is that you're testing. And the more and more complicated things get, the harder and harder that is.
So how and where does Python fit into the kind of testing that becomes necessary when you're dealing with these kinds of complex systems?
I've used, seen, or have heard of Python being involved in almost every aspect, right? You can everything from designing the systems, right? If you're talking about a server or a game or something like that, a lot of these modeling tools have direct ties and pipelining through Python to move things around to like process the data, convert it from one thing to another. I know that given behavior-driven development and test-driven development, Python would be a great asset for putting design definitions and specifications together. I haven't actually seen that happen, but things like Cucumber, and although that doesn't specifically have a Python module as is a good step forward of a way of defining a machine readable specification that you can then later maybe write some more elaborate AI systems to kind of decide for you based on history how to properly test a function, right? There's items involved in I've done test management tools, which involves everything from like recording what a test is and its procedure, the expected results, to what the actual execution of the test was, and what configuration you used to do it, and what the result was, and keep that whole history there for future reference, so that you can then make decisions, and for current reference, so that you can figure out where you're at with your process. And then in order to execute tests, if you're on the software side, there's PyTest, there's nose test, there's unit test to help with script execution, right? If you get into more elaborate stuff, there's Hypothesis, which you guys had the designer of that package on, right? That's pretty cool. I've actually hadn't had a chance to fiddle with, but that's a great thing to manage different configurations using the same type of test and things like that. Going into edge cases, you can look at message queuing using RAB and array task queue to go in and do automated execution. You can look at builds. You actually wind up using a lot of specific modules that come with a standard library, like OS, subprocess, and threading and multiprocessing, to like interact with a lot of the things that you actually wind up executing. Because especially if you get into low-level things, sometimes Python is not the best tool, so you wind up writing something in C. You wind up with C types. You do. Heck, I wrote a DHCP server once in Python, just to prove I could do it. I wound up being pretty cool. It gave me this whole sideband interface where I can just go in and change my network infrastructure fairly quickly without having to deal with anything else, and then set my systems up for OS deployments. You get involved in simulations. There's a few tools, different companies based on the products they make will have some sort of simulation system. A lot of them will use Python scripting to help you get into that. Like you could get like Intel, for example, if I remember correctly, has a way of like simulating at least processor behavior, and so you'd be able to like write some software that would run on your processor, and you don't even have to actually physically have it, right? You can obviously RESTful frameworks, anything that you can put in front of your other tools like Flask and Cherry Pie and Django and that type of stuff is fairly helpful to move things around in a very complex systems. In my environment, we moved around a little bit, and we wound up in this new site where we had to consolidate like a whole bunch of different test teams and test tools into one set of infrastructure running across multiple labs. And so we wind up picking REST communications using JSON, data exchange, and that type of stuff to be able to talk to all the different individual systems. So with the DHCP server, you can tell it what IP address to give a particular MAC address, and that can be driven by an OS deployment system that might be written in Perl or whatever, just using REST. And then when your OS boots, you can notify something else to update your list of resources that are available for testing, for example, through similar types of systems. There's performance monitoring is another thing that you can use, but mostly by driving some other tools through Python. And then you can, after you've done all your stuff, you have Python is great for analyzing results and incorporating other capabilities to see throughout history. Is this test always passing? Is this test always failing? What does my bug list look like? Which when I got this new build, did this generate a whole bunch of new bugs? How much time do I spend every time I get a new build? All kinds of stuff.
Yeah, there's definitely a huge breadth of concerns when you're dealing with any sort of large-scale testing. Basically, any small system can quickly become a large-scale testing if you are in an organization that puts proper emphasis on the fact that having well-tested systems are beneficial to their bottom line.
Right, and that's always an interesting thing, right? It is a balance to try, because if you just let the test people loose, you'll wind up with a big test budget, right? Because we want to test everything. What do you mean we got to risk assume? What is this? But yeah, it's always an interesting balance trying to figure out, where do you draw the line? Like, how do you split it up? How do you decide to move from one phase to another to final product release with as small as budget as possible, right?
Yeah, and how do you figure out which areas of the system are most critical to test, and are there any areas in that decision-making process that Python can feed information into that process?
A lot of that is highly dependent on what it is that you're doing, right? And a lot of it comes from actually being able to have a good picture of all of your interactions. If you're talking about and so an interesting thing as I'm thinking about here, if you're writing Python code, like if you're writing a complicated application in Python code, you can write Python code to detect like all of the different things that might be important to you. That's already written for you using the standard this module and looking through the AST. Looking at figuring out what to focus on, a lot of it is data analysis. Like you can look at, say, you can use Python to look at, say, social media and pull information out of that and see where most of your users are having issues. And you just run it, use the standard Twitter stuff, run it through NLTK, do a quick analysis of words that come out more often and relationship between them and things like that. And you can say, well, hey, my product's already out, but obviously I need to focus on these things over here because a lot of people are complaining about this. And then you can look at performance metrics as well, if that's a thing for the software that you're delivering. And of course, I kind of covered that, and pandas and SciPy and all that type of stuff is very useful to be able to look through all that.
So you've listed a pretty large number of different tools and libraries. If you can just pick a couple of your favorites that you use pretty regularly, and then also what are some of the areas where the available tooling that exists in Python falls short for your purposes?
Actually, I use CherryPy a lot. A lot of people aren't aware of it, but it's kind of like Flask. I'm not sure if it was there before Flask, but it's pretty much a way of mapping HTTP requests to functions. I use it quite a bit for putting a quick REST interface in front of something. And Celery is great for getting things automated and executed fairly quickly. And so that, I guess those are the major things I've been using most recently. Since I've been doing a lot of work in the actual management and status reporting tools, I've also been involved with the Postgre modules and SQL Alchemy and all that type of stuff. I find that I keep reinventing the wheel a lot with UI development, and I'll say that's one of the things where I think Python is still kind of needs to move forward a little more. There's quite a few libraries and they all do one specific thing, but if I'm trying to put together a site that needs to be used by a whole bunch of different browsers and needs to back-end load a whole bunch of other not so easily accessible tools or things that go off in my test infrastructure and queuing and things like that, it starts getting interesting. And of course, keeping track of all the data and being able to show it in some pretty way, it all gets interesting. And I always wind up going to web instead of what would probably wind up being some better if I could just write it all in Python and just get it over with. I wind up using a lot of JavaScript in the back end. And sure, you can put Django in front of all that stuff, and that'd be great. But you still gotta write all your JavaScript to make your charts or to interact with your systems.
There are some offerings that let you use Python to generate the data that gets shipped up to the front end, but at the end of the day, if you want to build a widely available UI, you basically your default choice these days is the web. As far as using Python for doing that visualization, basically there's Bokeh as one option, or there's Vincent if you want to translate it to Vega and eventually to D3. But yeah.
Yeah, I found myself recently, I've gone through different organizational changes lately, and I've had to like write very similar websites over and over again, and so I finally got tired of it a couple months ago. I actually started writing a Python module to write the websites for me. Yeah, I actually have a couple blog posts on that. I might actually wind up posting it up soon on GitHub. It could be interesting. I don't know. I wound up wrapping Bootstrap into a little Python module, and then putting using WebSockets to communicate with the UI, and then like all your backend can just be in Python.
That sounds pretty cool.
We'll see how that works out. I was at PyCon. We had Russell, you had him a couple shows ago with the
Russell Keith McGee.
Yes, he's done a great job with all this UI stuff. It's just very interesting, and how the deep dive that he's done to try to get all these common interfaces going and whatnot. So hopefully that pans out for him.
He's done some pretty remarkable work there. Listening to him dive deep on how it all fits together, I was pretty awestruck.
Yeah, it is definitely a lot of work.
I think that is one of the underappreciated projects in Python open source today, just simply because of its depth and what it makes possible. I really wish that it got more exposure and more love.
Yeah, for sure.
And given the breadth and depth of concerns that are encompassed with testing the various components of these large systems, what are some of the ways that a test engineer can get a good high-level view of the overall state and what the sort of historical trends have been in test successes or failures, and getting a good snapshot of the current state of everything that is under test?
So that's a very interesting question. There's a lot of tools out there, actually. Some of them really old, some of them fairly new, that are meant to do this, but nobody really kind of agrees ahead of time what it is that you're counting. They just know that you're counting something. So some tools wind up counting bugs. Some tools wind up counting test attempts, or some tools count only successful test attempts, things like that. And then some of them are just so customizable that you wind up having to have an engineer with the sole purpose of maintaining the tool that you bought from somebody else. And then only that guy really actually knows what it is that you're monitoring. It's kind of interesting how that whole thing has played out. I've written some tools myself, and it's highly dependent on what your test organization actually values. And so again, for a while there, I was in an org where everything was about test attempts. Like, are you 100% attempted? And that's good. That means you've gone through all of your testing. But in the grand scheme of things, it doesn't really mean anything, because if you had 1,000 tests to execute, and you executed 999 of them, say 999 of them passed, so you're 99% pass, 99.9% pass, and you're missing one test, and that one test is can my server power on? It doesn't. You need some qualification behind the numbers, right? So I've been in other organizations where they do defects, and defects is interesting. I think it's a bit better. So that way you track. Are you complete with your testing, and then where are you at with your bug status? Are all your bugs dispositioned? Meaning, are they closed, or do you have an action plan on what you're going to do with them over time, right? And that's an interesting metric, but that works mostly for what you've discovered, right? Which, if you have proper testing, then that's theoretically good enough. I think over the years I've developed in my head, mostly because I haven't been able to convince many people of this, kind of like a hybrid approach where you wind up with, you report your status based on what it is that you're actually testing. Like, so if you had 10 tests and your product is really, 5 functions, you report your status based on per function. So the status goes for the function. So you have an overall idea of where your product is, but you can also drill down into the individual things that you're supposed to verify and where those are at. And then that way you're qualifying the numbers. And then, obviously on top of that, you add defects and and where that's going. But it's very interesting. There's not really a standard. Different people like doing it different ways. It's a matter of figuring out what works for your organization. But the important thing in figuring that out, it should not be by who best interprets the data or, how do the numbers look better. It should be about what's the end quality. Well, like, how are my customers liking this?
Yeah, when you're digging that deep into the stack, it can definitely be easy to forget about the fact that the entire purpose for doing all of these things is to achieve the specific business objectives for the systems that are in play. Because if all of your tests pass, but none of them actually pertain to the end use case, then it doesn't really do you any good. So I would imagine that having a system where you can categorize the various tests by the end objectives that they facilitate for the people who are actually using the system would probably be one beneficial way of seeing at a high level, all these are the tests that passed for the happy path. The ones that failed are the ones that cover these, various edge cases. So most people can use the system, but if they're trying to do this particular thing, then they might have some trouble. So I realize that that's probably difficult, and that really being able to manage that information is, another avenue of complexity.
Yeah, it gets really hard, right? Because if you go down the developer side, right, you want to track like development functions. If you abstract out to the product that you're putting onto the market, then you want to track marketing requirements. But then you realize that your marketing, requirements or your product goals are too abstract. And so then you're like, well, this is part of that, but that's also part of that same goal, and this is also part of that. Like, how do you put it all together? And that's it's really important before running a test on a product, or at the very minimum before even deciding what your test organization should be doing, to sit down and have a conversation about what you're going to be measuring, because as we all know, you get what you measure.
Yep. And that also brings me to my next question. As you are tracking all of this information and categorizing it in the various ways, how are some of the ways that you can distill that information so that it can be presented to other areas of the business who might not have a thorough understanding of all the minutia of what the various tests are certifying?
Right. So most of the organizations that I've worked in use some form of project manager to communicate up to the business where things are at. And that's interesting because that person communicates the information gets filtered, right? Because you can't possibly go through all the, like you were just saying, through all of the low-level stuff. I think in the end, the better solution, which I've kind of gotten to that most recently, is to just have all of the data, have it always live in some application, whether that's a website or not, and then you gotta have different levels of abstraction, and you're gonna have to design that website or that application so that works for you, and that's where the trick is, right? Figuring out the data model that fits your product or your organization, such that you can collect your test results and be like, well, I had 1,000 tests, so many passed, so many failed, these are defects, and then find out some way of abstracting that up to, well, product goal X actually passed, these things and failed these many things, and, these are the defects, and then abstract that up to, yeah, we go or no, right? And it's a challenge. There really is no silver bullet for that, and especially depends on how much the business wants to get involved too, because some folks really want to look into the deep end, and so a lot of that I've accomplished through some form of hierarchical views. There's some interesting charts if you look at D3 and their gallery. I like their sunbursts, because it helps you do some good drill down where you can kind of abstract things out and to show that hierarchical data. Some of the other chord type diagrams are actually pretty good for that as well, where you can just show all the individual type functional stuff and group them together, and then relate that to the other, say to goals and things like that, and see how everything is going. And back to you have to decide what you're measuring. You also have to decide how you're going to look at that data ahead of time, because otherwise things start getting pretty complicated, especially if you change it in the middle of your product cycle.
So could that information also be used to provide a compelling business case for the resources required to test properly? I mean, I feel like we've all been in the position of, working at a place where you have to fight for every hour that you're given to build things. And a lot of the times, like you said previously, saying, give me 2 more weeks to write a really good test harness just isn't going to fly.
Right, and it can. It all depends on how well you can tie into the other side. Like, so you shipped your product, and then you have support, then you have warranty costs, then you have customer complaints and things like that. In the organizations I've worked in, there's like field replaceable units, so like and customer replaceable units, and engineers that go out to do all those replacements for you. And training costs are like, so for like a good example, when you go down training, if you make a product, and while it might be good for the business, if you make a product and then you also have to make like a really extensive training course, and at the end of it your customers still don't know how to use it, you know what I mean? You can look at, and a lot of that data actually exists somewhere in some database or in someone's spreadsheet, and you'd be surprised at how much people still use spreadsheets these days, and especially having things like Python for easily like keeping track of all this information. But if you actually gain access to that other side of your business, you can then start incorporating all that and say, hey, this bug over here that's involved with this system is very similar to a bug that we saw on another version of our product that was in that same system, and that generated number of customer complaints to a cost of number of field replaceable units, yada yada yada. So if it's having the data is the important thing, and a lot of times you don't get access to that. If you have a big enough organization, a lot of times it's really hard to get access to it. You wind up having to rely on just like making internal contacts to just like run around and make an effort to go and find it, right?
And another issue that frequently arises with test infrastructure is that it can, very, very often become unwieldy and difficult to modify, just like an improperly structured application. But because of the fact that a lot of times tests end up becoming a secondary concern and don't become properly architected, how are some of the ways that you can combat that sprawl and brittleness?
So you really have to plan for it. I mean, I hate to say that, but you really just have to plan for it. And a lot of times you're just not given that time to just sit back and say, well, hey, this product is going to involve these things. But you can usually schedule some time in maybe say once a quarter or something like that, where you step back and look at your infrastructure itself and say, well, we're mostly running on these things. What do we anticipate in our portfolio coming down the line? Well, this system is going to have 200 gig networking. So let's like adjust for that and see what we need to add. But so you need to be involved in future planning, and you need to make a conscious effort to go back and say and revise what's going on. And it's very easy. It's happened several times in my experience. You just kind of put your head down and just go with what you can, and then you wind up in these weird situations where you just don't have the infrastructure to verify things, or it's taking too long because you have to tear down what you have because you just don't have enough of what you need. There are, in the near future, some of that might be alleviated a little bit, at least in the industry I've worked in, due to like software-defined networking, containerization, and virtual machining, and things like that. I mean, containerization and virtual machining we've already been making good use of that to help alleviate some of the craziness. But when you're talking about extended hardware setups, like with a server, I remember back in the day when I used to do some integration testing. We supported a whole bunch of network cards and storage adapters, and all those storage adapters supported all kinds of different enclosures that you can plug into that, and some of them were 4-port adapters. So that's 4 enclosures per adapter, and then sometimes the servers that we were on supported an external enclosure of PCI slots, and so then you'd wind up with like these insane configurations where you're sitting with like 27 adapters plugged into your system, trying to like do different things, trying to make sure your system is still up because it's a supported configuration, trying to get into the operating system and trying to go through all of that. And like setting that up, a lot of times, that's another thing. People count execution time, but they forget about setup and teardown. And when you go off and you have a conversation, oh, but it's just a 6-hour test, well, why is it going to take you 2 days to do it? Well, I have to install all this stuff, hope it boots, and then like properly configure everything to the specifications of the test. The test will take care of 100 functions, but it takes a while to just get it going. And in order to actually wind up being able to execute all of that, you really just have to plan for it. You have to know ahead of time the server the product that you're going to be testing, what its capabilities are going to be. Then go back and do some planning to update your infrastructure if needed, and then plan for when requesting your time frame, your execution time frame, to be something big enough to handle all of the setup and teardown that you're going to have to do if you have to iterate on things quite a bit.
And this applies to other areas of engineering as well, but given the low-level nature of this kind of work, I imagine that maintaining proper visibility of what's being done can be pretty difficult. So how do you make sure that management and the other areas of the business can properly see and appreciate your efforts and the impact that it has on the overall success of the business?
That is very, very hard. That's all I have to say. In the grand scheme of things, the best thing is always to be able to tie what you're doing to the customer, right? Because then you can bring back and say, well, hey, a lot of times you find yourself, usually when you're doing these things really complicated, you find yourself in situations where there's going to be some special bid from a customer that wants some specific configuration, or it's an important enough customer that you want to be, involved to make sure that their environment actually is going to run whatever it is that you made. And in those cases, like if you can go back and say, well, hey, I got us these guys and that equaled so much revenue. Or, hey, we found this bug, and given the information I have from this other customer, we would have lost them. And, so that's, as long as you can tie it straight to customers and revenue and customer satisfaction, it's a lot easier to go back and have upper level management able to appreciate what you're doing. And then when you're talking about the lower levels of management, a lot of that is counting. And by what I mean by that is when you go into unit testing, you talk a lot about, you get a new build, you run all these tests with it, right? So a lot of larger cycles or timeframes in which you're verifying a certain level of complexity, a certain level of function for your product. Maybe not, end function. Maybe we're close enough to turn on the big stuff, right? You wind up going through a lot of iterations of builds. And so a lot of times, just simply being able to show, hey, I was able to run through, 500 builds in a time frame of like a month, and that meant verifying this and that this thing was good for every single one of those builds. And the output of that was, that my immediate test org did a bit more work, but the expanded test org never got those builds because of the work that I did, and that equals so much money or so much time saved in, wasted testing or wasted just putting the firmware on your product, or just swapping over to the new version of your application. That's a good way of looking at things as well. But you always got to tie it to something, and to something related to customers or time. It's a skill, I have to say. There are people that are excellent at that, and there are people that just don't even think about it. But it's something you develop over time.
So for anybody who's interested in moving their career in the direction of test engineering, what suggestions or recommendations do you have?
Oh, that's interesting. It's I thought, I don't know if there's even a path or even classes, and I'm assuming that by now there should be some test engineering courses in universities and stuff that go into more detail. There's a lot of literature out there on a lot of different methodologies. Especially if you're in software, you can read up on that, and that'll give you a good idea of what types of things to think about. There's so many different aspects, everything from build verifications to unit testing, to continuous delivery, to functional verification and integration, and behavior-driven design, and how that impacts testing, and test-driven development, which is a big thing these days, are also things you can read up on. As far as it's just, I can't say that there's one thing or like a certain all the stuff I just built up over time in experience and just like getting into it. I have found that it's very interesting in the sense of you don't only have to know how to, decide how to test. You also have to figure out how your product works. You need to be you need to be a developer. You need to understand what the implications of certain code is, so that you can properly design your tests. Yeah, I don't really have anything. It's very interesting, I was like, the more I think about it, I was like, there's got to be an overall, there's a couple books specifically on just test engineering and approaches to that, but I don't really know that. Yeah. Well, like I was saying before our interview, I'm looking into maybe possibly putting something together myself, so we'll see.
There you go. So is there anything that we didn't ask about that you think we should have, or any other topics that you want to bring up?
No, I think we're pretty good. I'd say we covered quite a few things here, so hopefully it's been useful for everybody.
I know that I definitely learned a lot more about the kinds of testing that go on in various organizations. I work as an infrastructure engineer, as a DevOps engineer, so I've been working on figuring out the best ways to apply tests to my infrastructure. So even just that gets complex enough when you have multiple different types of services interacting, and so...
Yeah, fun stuff.
So for anybody who wants to follow you or keep in touch with you and see what you're up to, what would be the best way for them to do that?
Twitter's probably the best way. I am at try-except-pass.
And with that, we'll move it on into the picks. My first pick today is the Samsung Galaxy Tab S2. My old tablet stopped working a couple weeks ago, so I had to get a replacement. Ended up getting the Galaxy Tab S2, and I am very happy with it. For a while, I kind of resisted going with the Samsung devices just because of the TouchWiz UI that they lay on top of it. I always wanted to go stock Android, but the UI version that they have on this is actually very well done, very unobtrusive, adds a whole lot of niceties that just make the overall experience with the tablet very nice. So definitely recommend it for somebody who's looking for a tablet and to use in their day-to-day. And my next pick is the Anker Soundcore speaker, which is a portable Bluetooth speaker that's got 24-hour battery life, sounds really good, has the volume, can go up pretty loud, and it still sounds nice and clear. So I've been using that for listening to music and podcasts and hooking that up to my new tablet. And it's pretty inexpensive too, so definitely worth taking a look if anybody's looking for a Bluetooth speaker to be able to use around the house or when they're out and about. And with that, I'll pass it on to you, Chris.
Thanks, Tobias. My first pick is a YouTube channel that I've picked before, but I'm picking a particular episode. It's called This Episode Was Written by an AI. Essentially, the folks from the Idea channel, the PBS Idea channel, which I've gushed about before on here, took their entire corpus of scripts and fed them into an AI as training material, into the Torch system with written in Lua. And what got spat out, they used as a script for a whole new episode. And the host, Mike, I can't think of his last name, he read the script as generated by the AI, and it's hilarious. I mean, it is really funny. And then also, if you ever watch the show, it's always interspersed with all these really kind of interesting visuals and internet memes and things like that. And they kind of stayed with that theme and memed to what the AI had written. It's just, it's funny and fun and worth watching. And my last pick is something that I don't usually do. I'm going to pick one of my own blog posts because I feel like I really had something to say this time. It's called The 3 R's, and it's about 3 aspects I see to being really key in making and keeping your software organization strong. So I'd be really interested in people's feedback or comments on that. Thanks. And Chris, what kind of picks do you have for us?
So I got one Python module that I talked about earlier. It doesn't get a lot of love, but I really like it, which is Cherry Pie. Definitely should take a look at that. It's maps HTTP requests to functions and does whole lot more than that. It's something like Flask, but different. My other pick is there's a service that's called etcd. That's written for it was written by the Core OS guys, which are involved in Core OS is like a Linux OS for the sole purpose of running Docker containers. And etcd is a distributed key value store. I haven't actually had a chance to get into the nitty gritty yet, but it provides a RESTful interface for you to just put and get information out, and it's distributed. So you're automatically backed up over whatever systems are running it, which is they use it to manage their Core OS deployments. I want to use it to manage resources and tasks for which to decide which tasks to queue on them. And I got one more thing, which is a book called Thinking Fast and Slow by Daniel Kahneman. If you haven't read that yet, it's very neat. It's a study on how your mind, how you process and how you think, and how you process information, and the differentiation between what he calls System 1, which is like your quick response, versus System 2 type thinking, which is your when you actually think through something, and your how that plays into your everyday life, and what system is in charge when, and that, like, after you read that book, you're like, oh wait, I was like on autopilot, so that was probably System 1, like stuff like that. It's pretty cool.
Yeah, I'll second that pick. I've actually just recently finished listening to the audiobook version of that, and there's a lot of really interesting stuff in there. It really talks a lot about how the different systems play together to create various cognitive biases and how that can affect your decision-making process in various situations.
Yep. I got one more thing. I just got back from traveling around for a little bit. I was in Spain, and I have to say, if you have some time, you should book a flight to Spain. Spain is very interesting. You can go to several different cities, and you'll get a very different experience, because Spain is like 5-ish different regions, and they all have their own little subculture and all of that. So, like, I've been to Barcelona and Madrid, and while I was in Madrid, I went to Segovia and a couple other towns around it, and it was great. Everybody should check it out.
Well, we really appreciate you taking the time out of your day to join us and talk to us about your work and how Python fits into it and the various types of testing and complex systems that we should all be thinking about. So thank you very much, and sure. I hope you enjoy the rest of your day.
Thank you. Thanks, guys.
Thanks. Bye-bye.